So let us start with this simple laws of exponents only. First of all, let us discuss them like for the 10 to 15 minutes, then we'll do the question part. Okay. Okay, so if we talk about the simple exponent laws, okay, first of all, exponent laws or laws of exponent. See, the basic thing that you need to understand that what actually exponent is. Okay, so we have any expression of this form, a to the power b is known as exponent. What actually is that? This a is called the base here, and this b is called the exponent, or we sometimes we call it the simple as power. Okay, so this a is base. Now we are raising some power or some exponent to it. Now what it actually means, okay, so let us understand using the laws only. So let us say simply first law, that is a power n. Now a is some number here and n is also some number. So what actually a power n means that we are multiplying a with itself how many times? N times.
Mm-hmm.
Okay, so let's say if we take one example, 2 power 3. So that will be 2 into 2 into 2, that will be 8. Because we are multiplying 2 to perform that experiment or that particular activity or that particular thing. Okay, so a power n is n times. Now we have a very basic law. You must have seen that a power n into a power m is sometimes called to be what? A power n plus m. Okay,
Mm-hmm.
so why we are doing that? So let me give you a very basic proof. Okay, I'm not going to give the proof of each and everything because you'll understand by yourself only. But let me give you the proof of basic things at least. So a power n is what? Multiplying with a itself how many times? N times. And
Yeah.
then multiplying a with itself how many times? M times also. Then we are taking the product of this whole thing. So we're multiplying a with itself n times, and we're multiplying a with itself m times, and then we're multiplying this whole expression. So can I write that I'm actually multiplying a with itself n plus m times?
Yeah.
So I can write this directly. That's how we simply add the power. Then if we divide it, so a power n divided by a power n is simply what? A power n minus m. So
Mm-hmm.
same proof will go on. Like okay, in the numerator we have a getting multiplied with itself how many times? N times. And then we are saying that a getting multiplied with itself how many times? M times. Now try to imagine and try to observe that can I cancel out this a with this a, right?
Yeah.
Now, if I say that n is greater than m, that means I have more number of a in the numerator than the number of a that I have in the denominator.
Yeah.
So I will cut m is from the numerators. So how many a are left here? N minus m.
Mm-hmm.
So I'll have how many a's left out? That will be n minus m. So that's why I'm writing a to the power n minus m. Got it? Got the proof?
Yeah.
So that is the second law. Okay. Try to learn them. Okay. Here only, then we'll do a basic revision, then we'll start with the question part. Okay.
Okay.
Then let us come to the third part. A power 0. So this is a very principal law. Okay. Sometimes we have a direct result, so we need to learn them directly. That is only one only. So whenever we raise power 0 to any number, that will ultimately make that number 1. So
Mm-hmm.
10 power 0, 1. 100 power 0, 1. Minus 99 power 0, 1. Okay.
Yeah.
Fourth law, if I raise power 1 only, so that will be a only. Okay, so minus 88 power 1, that will be minus 88. Always remember that.
Yeah.
Fifth one, a power m is simply what? If I want to, just remember one thing. Okay, I'm just, you can note it down by yourself also.
Mm-hmm.
If you take or transfer any number from numerator to denominator or denominator to numerator, if you are taking any number or transferring it from numerator to denominator or denominator to numerator, the power of that number changes by sign, sign sign.
Mm-hmm.
Okay, so that means if I want to take a power m in the denominator, now I don't have anything in numerator, so I'm just putting 1 here. So this power will become minus m. Got
Okay.
it?
Yeah.
Similarly, let's say if a power minus m, so this will become 1 by a power m.
Okay.
Okay, so always remember that thing.
Yeah.
Then if I have, let's say, a into b power m, like we have power m, okay, that is whole raised to some product of two or three number, then you can open the bracket by distributing that power to each and every number.
Yeah.
Let's say if I give you one example, let's say 12 raised to power 4. So I can write it to be what? 4 into 3 raised to power 4, or basically 4 power 4 into 3 power 4. Got it?
Yeah.
So that can, like, you can perform the reverse operation also, like a power m into b power m. We can simply multiply a and b, and then we can raise the cumulative power, that is m, to the product of a and b.
Mhm.
Okay. Then one of the most important property, that is this a power m whole raised to power n. Like you can see that we have a term a power m, but I'm raising whole raised to power n. So here we can write a is raised to power m into n. Okay, let me give you a very basic example. 2 power 2 raised to power 3. Now, is this really equal to 2 power 6? Like 2 power 2 into 3, 2 power 6. Let us see. Okay. So, here, actually, what is happening? 2 power 2 raised to power 3. So, ultimately, in the bracket, do I have 2 into 2?
Yeah.
2 power 2 is 2 into 2. Now, how many times do I have to repeat 2 into 2? 3 times.
Yeah.
So, 2 into 2, 2 into 2, 2 into 2. But actually, in the end, how many 2s I'm having? 6. So that
Yeah.
is 2 power 6. So that's why we are getting it. Okay.
Yeah.
And you can change power also. Like, okay, you can bring the higher power inside, like outside power inside and inside power outside. So it is ultimately going to same only, because m into n is equals to n into m. Like multiplication is commutative. A into b is equals to b into a. Okay.
Yeah.
So we have done the 8 laws. Now, one more important law. Let's say if I have a power 1 by m, so it is nothing but mth root of a. If I want to give you one example, the most common example is, let's say m is 2. So if you remember that, I can write 2 power 1 by 2 as square root of 2. Like we generally note, write what, 2 here, right? Or
Mhm.
let's say if I have 4 power 1 by 3, so it is cube root of 4. So you can see that we have done this law, this law, this law, this law, this law, this. Yeah, one more thing is remaining. Okay, that is, I don't think, very much hard to interpret. Like if I have a by b power m, so if you remember in the multiplication, what we had, like if a into b power m is a power m into b power n, same thing will happen here also. You can
Yeah.
distribute it like separately.
Mhm.
Okay, so we have done this thing also. Then this is the log part. Okay, we'll do that later on. But now we can solve the questions. Okay, so I'll solve 2 to 4 questions. Okay, so that you can get an idea how to solve them. Okay, because these are the most like prevalent question. Okay, when it comes to the questions of the exponent. Okay, like
Mhm.
they'll ask you the how to find the value of any variable. Okay, using some expression. Like here, 3 power x is 12.
Mhm.
Okay, but that will include the logarithmic. No, 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 no. Right now we have not. Let us learn the logarithmic also. Then we'll go for these questions. Okay. So
Yeah.
yes. Now, because we have a connection between the exponential and the logarithmic laws. Okay. So first of all, let us understand what logarithm is. Okay. So logarithm. So it simply looks like this: log a to the base b. Okay, we call b to be the base here and a to be some number.
Mhm.
Now, what actually this thing represent? Like, okay, the first thing that should come in our mind, that what this thing actually represent. Okay, like what log a to the base b is asking us to calculate. Okay, so the thing is that the definition here we have for this is that, like, what will be the value of this thing. Okay, ultimately that I'm going to tell you, that it is a question to, it is a question, and what that question is, what power should we raise to b in order to get a. Note it down.
Mm-hmm. Okay.
Done. Okay, so let's say if I give you log 8 to the base 2, or let us take more easy example, 4 to the base 2. So same thing here, what is the value of a is 4, b is 2. Now if I ask you the same question, what power of b should you raise to get a? So what will be that power?
2.
2. Very good. 2 raised to power 2 is 4. The value of this thing is actually 2 here. Okay.
Mm-hmm.
Similarly, let me give you few more example. Let's say log 8 to the base 2, log 27 to the base 3, log 243. You can use the calculator right now, okay? Because I'm just giving you a little bit more complicated calculation so that you can understand the concept way more better, okay? 3. Yes. Give me the answer for these three questions.
2 to the power 3, so it's 3.
Yes.
3 to the power of 3.
Yes, 3 cube is 27. 3
Mm-hmm.
into 3, 3 square is 9. But we know that 3 cube will be 3 into 3 into 3 into 3, that will be 27.
35.
Sorry?
35.
No.
Um,
Do you
mm,
think 3 raised to power 35 will be 243?
um,
Try to raise power of 3. Just calculate in the your calculator 3 power 3, then calculate 3 power 4.
um, 3 power 5.
Yes, 3 power 5 because 3 power 4 is 81, and
Yeah.
then if you multiply 81 with 3 you'll get 243. So that will be 3 power 5. Okay. So now I hope we are getting the idea. Now if I ask you what will be the value of this thing?
Um, I'm not sure.
Go for it. You can use the calculator. That's what I'm saying. That take the field. Try to raise the power. Root 2 raised to power 2. Then try to raise root 2 power 4. Come on. Okay, just try to tell me one thing. What will be root 2 square?
Oh, root 2 squared.
That will be
1.
2 only.
Yeah, 2. Sorry.
Yes. Now we want to make it 16.
Mhm.
So if I raise power 4 here, I know 2 power 4 is 16, right?
Mhm.
That means I have to raise power 4 here also.
Okay.
That means 8 will be your answer. 2 into 4, 8. Okay.
Yeah.
Now calculate using the your calculator. The
Yeah.
root 2 power 8 is coming out to be 16 or not.
Yeah, it is.
Okay. So I hope now you are able to get the feel of the logarithm, that what actually this is asking us. It is basically a question to you only, but they
Yeah.
are writing it in this way.
Okay.
Okay. Okay. Now let us come to the laws of logarithm or basic fundamental identities. Okay. So let me write simply formulas. So first thing, log a to the base b. If I'm saying that it is p, then I will say that a is equals to b power p, right?
Mhm. Yeah.
It is vice versa also. Like if I say a equals to b power p, then I can write this thing same here.
Okay.
Second, log a to the base c plus log b to the base c. If they have the same base,
Mhm.
then here I can write the combined term like this. Like I can multiply a and b and I can write it with base.
Okay.
For example, let me tell you like okay how it we can actually verify it. Okay, let's say log 16 to the base 2 plus log 4 to the base 2. Now, if I actually calculate this value, not using the formula, what is its value?
Um,
4?
it's 4, yeah.
Yeah, 2 power 4. Try to see, if you want to calculate, try just multiplying it. 2 into 2,
Yeah,
4. Then 2 into 2 into 2, 8. Then I have to do it, multiply once again 2. So it will be 4. Here it will be 2.
yeah.
This one. So we are getting value 6. Now let us use the formula. So using the formula, what we should do? We should multiply this, right?
Mhm.
This is coming out to be log 64 to the base 2. So can you tell me what actual value here we will get?
6.
Don't guess it, okay? Just calculate it using the calculator.
Okay. Yeah, 6.
So you can see that we're getting the same value, right? So that's a formula. Okay, formula is verified now. Now, if we have the negative sign in between, like this, then same thing happens, but what will happen here? A by B. Like you'll divide. Okay. Now try to imagine one thing. If you remember in the exponent, okay, what was happening there? If the two things are in division, then their power gets subtracted, right? And here if two things are in subtraction, then their numbers are getting what, divided by each other. So it is nothing but a reverse process only. Definitely not, they are not looking same, but we can get the feel in the reverse way, right?
If there's a question and it's like dividing it, would it also be minus?
Sorry, I didn't get you like perfectly, but can you
So
please tell
like,
me like yes.
example, it's like log C A over B, and then so you just also subtract it. Like, is it?
No, 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 no. We are coming to that property also. Okay, we are coming to that property also. Yes. Right now, this A by B is in the log only. Okay, like here, like this. Let me
Okay.
give you again. Let us take the same example. So without using the formula, it will be what? 4 minus 2, that is 2.
Mhm.
Using the formula, it should be log 16 by 4 to the base 2. That
Mhm.
means 16, 4 to the base 2. So we are getting 2 here again.
Okay.
Which formula? 4. If we have number 1 here, okay, so any base you put, the answer is 0 only. Because if you remember, if I raise power 0, the answer is 1 only always. So that's why here we are having, if we have the number as 1, then what power should you raise to the base? That should be 0. Okay.
Okay.
Same thing, if we have number and base same, what should be the power? That should be 1. Because I told you in the exponent laws also that a power 1 is a only, right? So same
Yeah.
thing happening here.
Okay.
Then now comes the base changing property, very important. What is that? Let's see if I have log a to the base b. Now, let's say I'm not comfortable with the base b here. Okay, I'm not comfortable with the base b here. So what I'm going to do here is that I can change the base like this, log a by log b, and I can put a base of my choice. Let's say c.
Okay.
Okay, so let's say if I have log uh, 10 to the base, let's say 6. So I can write it like log 10 to the base 2 divided by log 6 to the base 2. Okay. But what if I take the base to be a only? Like if I have a to the base b, I'm taking the base of my choice, but that is a. That will be what? B to the base a, right? Yes. So we just learned one property that this should be what? 1.
Oh yeah, 1.
So it will come out to be 1 divided by log b to the base. So you can see that here we're getting one very beautiful relationship, that log a to the base b is nothing but 1 by log b to the base a.
Mhm.
So base and number are changing their position if we take the reciprocal.
Okay.
So let's say if I give you log 2 to the base 4, so that is nothing but log 4 to the base 2. Okay.
Yeah.
Then if I have, let's say, a number outside, like a number that is getting multiplied with log a to the base b, okay, then this p can come in the power inside.
Okay.
Let me give you one example. Without using the formula, this should be what? 3 into 2, that is 6,
Yeah.
because this value is 2. But using the formula, this should be log 4 to power 3, 2. What is 4 cube? That is 64.
Yeah.
4 into 4 into 4. Now, what is 64 to the base 2? That is 6, right? We
Yeah.
just calculated in the previous example. Are you writing the laws or not? Because I'm writing them very much quick manner. I don't think you're writing down.
Um.
Okay, okay, okay. Then that's great. Okay. So we have done the 8 laws. Okay, let me see that what we actually had to do. So we have done this thing. Okay. We are going to learn about this natural logarithm right now. We have done this. We have done these properties also. Change of base, if you remember, we just did it, right?
Yeah.
Yes. Okay, now let us come to a very interesting part. Okay. See, we just learned that log a to the base b is there. Okay. Now, in we can take any value of b, right?
Mm-hmm.
Always remember one thing. Okay, that just for your knowledge only, that this a should be always greater than 0. This b should be greater than 0 and it cannot be 1. Like these are the basic rules. Like if something is defined in the world, then it should follow some rule, right?
Yeah.
Okay, so these are the thing that logarithm is defined for these properties only. If a will become negative, then we'll say that okay, logarithm is not defined. Or if base become negative or base become 1, then we cannot say that logarithm is defined. So always remember this basic property, that to be defined, okay, the number should be greater than 0 and base should also be greater than 0, but also base cannot be equal to 1.
Mm-hmm.
Now, we have, like, if base is greater than 0, then we can have infinite values of b, right? So what they did, that if they wanted to create some questions on the logarithm, so they came to one point that okay, we'll fix the base. That is, we'll simply say that we'll take the natural base. They invented one number, natural base, and its notation is simply given by e and is approximately value. You don't need to remember the value, not at all. It's given by 2.7 something. Okay, but let's say if I'm giving you, let's say, log 5 to the base e, so rather than writing log 5 to the base e, they're simply writing it ln 5.
Okay.
If you can see that on your GDC also, you can see the symbol ln. So
Yeah.
ln is nothing but log only, but with base e. So rather than writing like log log 5 to the base e, if I simply write ln 5, so it is understandable that okay, it is nothing but log 5 to the base e. And sometimes if they are writing like this, let's say log 5, so it is log 5 to the base 10. So you're, if they're giving you this thing, then the base is 10, the default base is 10. If they are asking you the value in ln, then the base is a. So remember that one.
Yeah.
No, I'll give you 1 minute, note it down in your language, then I'll just explain you one more thing. But please first of all write it down in your language, that okay, what actually ln means, and if they give me simple log without base, then what it actually means. Now let us come to that point. We have actually talked about that thing, that okay, something there should be like okay, we can relate exponent to logarithm and logarithm to exponent. Okay, so how and actually what is happening here? Okay, so let's see, if I have 3 power x equals to 12.
Mm-hmm.
Now you can see that 3 power x is 12. So if you remember, when I had a power p is equals to, sorry, in the log, if you remember that if I have log a to the base b as p, then I could write it like this, right?
Yeah.
So try to imagine that if I take log on both side with base 3. Now, why I'm taking base 3, I'm going to explain you in a while, okay? But right now, just understand that why we are taking log to remove the power. How? So this will become log 3 power x to the base 3
Yeah.
equals to log 12 to the base 3, right? But if you remember that I told you one property, this property, that if I have p outside, it can come to the power of a
Yeah.
and it can go back also. Like let's say if I have log 2 cube to the base 2. So I can write it 3 times log 2 to the base 2. Okay.
Mhm.
Okay, one property we are remaining to study. Sorry. Let me write this property again and one more property. Okay. I'm writing it here only. Okay.
Okay.
It's 9. So I'm writing it back again. Let's say if I have log a to the power p to the base b. So it can be written as p times log a to the base. Okay.
Mhm.
And 10th property, let's see if I have power of this b, like power is for the base, so that can also come outside, but that will come in the fraction like 1 by p.
Mhm.
Now Sana is thinking that okay sir, we have the formulas, but now you are telling me way more number of formulas. How am I supposed to learn them in one day, right?
Mhm. We have a formula booklet.
Okay, so that is fine. Okay.
Yeah.
But right now I just want you to understand, at least take the feel of each and every formula. It should not be that I have written it and you have to mug it up. No.
Yeah.
Like there is some logic. I am giving you example for that purpose only. Okay. Like here. Now I can write the left hand side to be x times log 3 to the base 3, right?
Yeah.
Now can I write 3 to the base 3 as 1?
Yeah.
So x is coming out to be log 12 to the base 3. Okay. This is your answer.
Okay.
Let me do few more questions. Let's say if we take 8 power minus y to the base, sorry, to equal to 2. Now, do you know that for 8 and 2, can I take a log with a common base which will make the calculation easier?
Yes.
Which base? 2?
Yeah.
Right, that's good. Okay, so what, see, that is the intuition that you have to create an exam, and that will come after doing at least like 10 to 15 problems. Okay,
Mhm.
so we have to do that. We're going to do that today only. So if I take log on both side with base 2, so minus y will come outside, right?
Yeah.
And this will become 8 to the base 2, and this will become log 2 to the base 2. So
Mhm.
this will become 1,
Yeah.
this will become 3.
Yeah.
So minus y into 3 is 1. So can I write minus y is equals to 1 by 3, or can I write y equals to minus 1 by 3?
Yeah. Okay.
That's how we solve the question. Okay.
Mhm.
Now,
Also, sir, at the end of the class, like in the last like 5-10 minutes, I have one or two questions that I want to ask you for like logs.
yeah, sure. You can ask me right now also, but yeah, okay, let's just do 4 to 5 questions, then we'll discuss your doubts.
Okay.
Okay. Okay. Now, in these number of questions, are you able to see them? Like it is a little bit blurred.
Yeah. I
Okay,
can.
I'll write them down. Okay, so 2 per x equals to 0.7. Like solve all of them, then we'll discuss the answer together. Okay, because then it will create trouble. Just do them in a rhythm. Okay, so then you can do 8 per minus y equals to 8. See, don't go for this. Go for this. I'm writing down. Okay, I'm modifying them a little bit
Okay.
for the simpler calculation. Okay, then 4 power x by 2 minus, let's say, 16 equals to 0. Then let us take fourth question. 5 power t plus 3. T plus 3 is in the power 25. Then we have 16 minus 3 power 4 plus x equals to 0. Then we have 5 power x equals to 6 power x minus 1. Then 4 power 5 minus x equals to 11 power 2x minus 1. And last one, 2 power 3y minus 2 equals to 3 power 2y plus 5. 6, 7, 8 are very good questions. Just try to solve the first five, then I'll explain you the sixth one, then I'll ask you to solve the 7 and 8. Okay?
Mhm.
So, what you've done with the first question?
X equals 1.
X equals to 1. No. See, we'll take log on both sides with base 2.
Okay.
Or you can take with base e also. So
Mm-hmm.
this will become x times, like x times log to the base 2, that will become 1. So this will become x equals to 0.7 to the base 2.
Oh,
What about the second question?
I got -1. Wait.
That is correct. That is correct.
Okay.
See, you can do it directly also, but if I take log on both sides with base 8, so
Mm-hmm.
this will become minus 8 log 8 to the base 8, right?
Mm-hmm.
And here also it will become log 8 to the base 8. This will give you minus y equals to 1, or basically y equals to minus 1. That is absolutely correct. Very good.
Okay.
Okay, let us go for the third question. So, with what base you have taken the log?
Oh, I didn't do it log. I just solved it.
Yeah, that is also fine. I think you have put x by 2 equals to 2, right?
Yeah.
So x will come out to be 4. That is also fine.
Okay.
Not an issue. What about the fourth one?
I got -1.
Negative 1 is correct. Okay, so again you did it directly, right?
Yeah.
What if I do this thing? Yes. This will make question a little bit harder. First of all, my first question is, with what base you will apply the log on both sides?
5?
Good, very good. Now go for it.
I'm not sure.
Okay, so we have taken the log on both sides with base 5. So
Mm-hmm.
this will become t plus 3 times log 25 with base 5 and log 125 with base 5, right?
Okay, yeah.
Now try to see that, okay, what power you should raise for 5 to get 25. That will be 2.
Yeah.
And you should know that 5 cube is 125, or you can use it using the GDC. I've told you that if you're not able to remember it, try to calculate the powers using the calculator. Or you can do it with like, okay, simply like writing that down. Okay, 5 square is 25. Now if I have to calculate 5 cube, that will be 25 into 5. That
Mm-hmm.
will come out to be 125. So this will be 3. So we'll get the equation that t plus 3 times 2 equals to 3. So what will be the value of 3 here?
Um,
That will be 2t plus 6 equals to 3.
yeah.
That means 2t equal to 3 minus 6, that is minus 3,
Mm-hmm.
or t equal to minus 3 by 2.
Okay.
I know I have messed up a lot here, but I hope you understood.
Yeah, no, I understand.
Okay, okay, okay. So 4 questions are done. Let me take the 4 question down there, so that. Then if we talk about the fifth question, so that will be 16 equals to 3 power 4 plus x. Then take, then let us take, see, if you are not able to recall, or if you're not able to think that what base you should take, always take base 10 or the base to which you have raised the power with. So I'll take the base with 3 only. So that,
Mhm.
okay, I can isolate 4 plus x. So log 16 to the base 3, and this will become 4 plus x only, right?
Yeah.
So this will give us x equals to log 16 to the base 3 minus 4. This is your value of x. Now I'm solving which option you want me to solve. 6, 7, 8.
6.
6 is easy. Tell me 7 or 8.
Uh, 8.
Okay, I knew that. Okay. Yes. So here we can see that 2 raised to power 3y minus 2 and 3 raised to power 2y plus 5. Okay.
Mhm.
So we can take any base, either 2 or 3. Okay. So let's say if we go for, like, which base you want to go for?
Um, 2.
2. So this will give us 3y minus 2 equals to log 3 power 2y plus 5 to the base 2. Yes or no?
Yeah.
You understood, like, okay, how I have written 3y minus 2 directly on the left hand side.
Yeah.
Because log 2 to the base 2 will become 1 only. Then 3y minus 2, can I bring this power in front of the log?
Yeah.
Now, for a second, let us assume that this is something, let's say t, for the like better calculation, simpler calculation.
Mhm.
3y minus 2, 2y plus 5 times t. Okay. Now, we need to calculate value of y here. Okay. So 3y minus 2, focus on the screen. Okay.
Mhm.
3y minus 2, 2yt plus 5t. Yes or no?
Yeah.
Then I'm going to bring this term here. So 3y minus 2yt. I'm going to take minus 2 that side, so it will become plus 2, right?
Mhm.
Can I take y common?
Yeah.
So y times 3 minus 2t, 5t plus 2. So can I say that y equals to 5t plus 2 divided by 3y minus 2t?
Yeah.
Now can I put t back? What was t? That was log 3 to the base 2.
Yeah.
So this will become 5 times log 3 to the base 2 plus 2 divided by 3 minus 2 times log 3 to the base 2.
Okay.
That's your answer. Now
Okay.
using the calculator, it is very, like, you simply calculate the value of log 3 to the base 2 separately on the calculator, and then you simply calculate 5 times that value plus 2 whole divided by 3 times 2, 3 minus 2 times that value. Okay.
Yeah.
So now you have to solve 6 and 7 both, then give me the answer together of both the questions. Done?
Yeah.
Okay, I'll give you sixth one in the homework, but I'm going to explain seventh one. Okay?
Okay.
Yes. So seventh one, what log with what base should I take?
Um,
4.
yeah.
So this will become 5 minus x equals to 2x minus 1 log 11 to the base 4, right?
Okay.
Understood?
Yeah.
Now we're taking 11 to the base 4 to be, let's say, t only. Okay. Just for, like, okay, for the sake of simplification, like, okay, I don't have to write it again and again. You
Mhm.
can write it again and again, not an issue. And if you write in the answer copy that let log 11 to the base 4 t, okay, then that is also acceptable. Okay. So
Mhm.
this will give me 5 minus x, 2x minus 1 times t. Now
Mhm.
can you tell me what will be x in terms of t?
Um, let me check. 24x equals 5t.
Hmm?
24x equals 5t.
24. No, I don't think it will come there. Like, okay, so this will become 5 minus 2xt, or not 5 minus 2xt. Let's just bring this minus t on left hand side. So 5 plus t, and I'm bringing this minus x on the right hand side. So 2xt plus t, sorry, plus x.
Mhm.
So this will give me 5 plus t. X I will take common, so 2t plus 1. From here, I can see that x will be 5 plus t divided by 2t plus. And we can put the value of t now.
Okay.
Okay.
Mhm.
You calculator is allowed in this examination, right? Like
No,
tomorrow.
no, it's not.
Okay. Then how you are supposed to calculate the value of log then?
Um, I think we're supposed to change to like exponential or just simplify.
Yeah, you I think you are supposed to do that only thing then. Okay.
Okay.
This is 32 raised to power minus 1 by 5 equals to 1 by 2. This is 256 raised to power 2 power 8. This is 216 36 power 1 by 2. Index notation, that means this notation, okay?
Okay.
In
Um,
this, yes.
is there a way that I could send you a question right now? Like, how do I send it to you right now?
That will be a perfect way. Like, okay, you just simply mail it on the operation and just tell them that, okay, please forward this mail to Ronak sir as soon as possible. Okay, then I think I'll receive it through mail. Because I cannot provide my mail. Okay, that is against the policy, but definitely you have the TestprepKart operation mails, right? So
Yeah.
just take the screenshot, whatever how many doubts you're having, put
Mhm.
it on the mail on the TestprepKart operation, and please do write send it to Ronak sir.
Okay. Or could I put it in a in a document and then send the link in the chat?
That is also fine, I guess.
Okay, yeah, I'll do that now then.
Yeah, because you cannot post pictures or anything, but yeah, link is fine. Yes.
Yeah. Okay. Okay, I sent it.
Yes, yes.
Can you see it?
Just a second, it is loading. Yes, yes. Okay, let me take the screenshot. I'll put it on the OneNote, then we can discuss them.
Okay. For the first question, I know how to do part A, but I'm not sure about part B.
Okay, okay. Just a second. Yes. So you're saying that you don't know how to do the second part, the ln45, right?
Yeah.
See, ln3 and ln5, right? So what
Mhm.
they're saying, write the following expression in terms of x and y. So I can see that, okay, this is nothing but sorry, not log. This will become ln5 minus ln3. So this
Yeah.
will simply become what? Y minus 6, right?
Yeah.
Now we want to simply solve ln45. Okay, now we have no idea what to do with this thing, right? But do I know that if I do the factorization of 45, I can write it to be 15 times 3, or
Mhm.
I can write it to be 5 times 3 into 3, or simply 5 times 3 square, right?
Okay. Yeah.
So can I write ln 45 as 5 into 3 square,
Yeah.
or can I write to be ln 5 plus ln 3 square,
Okay. Yeah.
or ln 5 plus 2 times ln 3?
Oh. Okay.
So this will become y plus 2x.
Okay.
Always remember that. Okay, you have whatever like basic values that they have given you, you try to make that typical value that they are asking in the question to convert it into the simpler form. Okay,
Okay.
that is the case.
For the next question,
Fifth question.
yeah, I knew how to do it, but there was one step that I got stuck on. So like,
Okay, this is also the part of fifth question.
yeah, yeah, yeah. That's the whole
Okay,
question.
an arithmetic sequence has the first term lna.
Mhm.
Now, first of all, let us understand what was arithmetic sequence. If you remember, first term is a, second term will be a plus d. Okay, it will go on. Or if we talk about the nth term, that is the okay un. So that
Okay.
will be what, a plus n minus 1 d. If you remember, d is the common difference, right?
Yeah.
So here they are saying that ln a is the first term, and common difference is ln 3.
Mhm.
13 term is 8 ln 5. So they're saying that U13 is 8 ln 5, right? 8 ln 9. Now what was the actual formula of U13 we can make? That will be A plus 12D.
Yeah.
What is the first term here? ln A.
Yeah.
What is the D?
Um,
ln 3.
Elementary. Yeah.
And this should be equal to 8 ln 9.
Mhm.
So this will become what? ln A plus 12 ln 3, right?
Mhm.
Now, definitely we can calculate the value of what? A here, but how? So always remember, Sana, that you create either the same base or same number. Like here, same base is already there. Like all are with base E only. Like all are ln only.
Mhm.
But I know one thing that this is 9. I know one thing that I can write ln 9 as ln 3 square, right?
Okay. Yeah.
Or this can be written as 2 ln 3.
Mhm.
So this whole thing, if I can write ln minus 2 ln 3, so what the RHS will become 8 into 2, that is 16 ln 3, right?
Mhm. Yeah.
Now on the right hand side, I have 16 times ln 3 and I have here 12 ln 3. So can I write 16 ln 3 minus 12 ln 3, which will be nothing but 4 ln 3.
Yeah.
And this is ln A.
Mhm.
Now can I write this as ln 3 power 4?
Okay.
Like, understood or not?
Yeah. Understood.
Now, always remember two basic properties. Okay, let me tell you. If a power m is a power n, like here base is same in the power exponents I'm talking about. If a and a are same, then this power must be same.
Okay.
Same goes for log also. If log is having same values and with same base, then that says that a equals to b. So here we are having ln with same base. So a should be equals to 3 power.
Okay.
Note it down, please. This is very good question. Like this is a very good question, and also the property that I mentioned.
Yeah. Okay.
Done.
Yeah.
Any other doubts?
No.
Okay. So please go for these basic question.
Mhm.
Solve the first question fully, like all the four sub parts I've given you. Then we'll discuss the answer. Then we'll go for the second question. Okay. What about the second question? Second question, you just need to, okay, for the third question, I'll get the answer. But for the second question, you need to use that property only, that log a to the base b is p, and a will be b power p. So that is easy, right? So
Mhm.
125 will be 5 power 3. 16 will be 2 power 4.
Okay.
5, 100,000 will be 10 power 5, right?
Okay.
So here 1 by 8 will be 2 power minus 3.
Mhm.
Okay, go for the third question. I want answers. Okay, like solve all of them, solve all the six subparts. Okay, and tell me the answers.
Okay.
Okay, so what's the answer for the A part?
It is 2.
Good. Then for E part,
Oh, for E, it is 4.
good. For I,
-2.
negative
2.
2. Yes. C,
7.
correct. Then H,
-1.
K,
1/4.
that is correct. Okay, so do we have any other question?
Let me just quickly check.
Sorry?
Let me just check if I have another question.
Okay, okay, okay.
Oh yeah, I do.
Okay. Yeah,
Okay.
you can send me then.
I just added it to the same document.
Okay. Okay, this is one question only. For that, let me just tell you one very basic thing. Okay. Like graph of a per x, like graph of exponent, graph of a per x. It goes like this. This is for a greater than 1.
Okay.
Actually, this is for a greater than 0, not. And when x is also positive, okay?
Yeah.
But when a is positive but power is negative,
Mm-hmm.
okay, so the graph will start from here and it will go down like this. This point is 1 comma 0 comma 1, because you can see that a power 0 is 1, right?
Yeah.
And also one more thing, that this is for a greater than 1. This is for a, like, okay, a greater than 1 but x less than 0. What if a is between 1 and 0, like fraction? Okay, so same thing happens, but it will change. Like, okay, for x greater than 0, it will be decreasing graph.
Okay.
So it will be like this. And for a belonging 1 to 0, but x is negative, then it will be increasing. So you can see that there are four kinds of graph. If a is greater than 1, so power is positive, so definitely it will be increasing. Power is negative, it will be decreasing. But when a is less than 1 and greater than 0, that means it is a fraction, then it happens like reverse thing. Like for x greater than power positive, it will be decreasing. And for, because you can see that if I have, let's say, 1 by 2, now if I keep increasing power, the value will keep decreasing. 1 by 2 is 1 by 4. Here it will be 1 by 16. So you can see that it is decreasing. So it is natural to go down. Okay.
Mm-hmm.
Have you noted them down?
Yeah, I have.
Now, if I go for the logarithm graph, so if I talk about ln x, that means log x to the base e, its graph looks like this. This is 1, comma 0.
Okay.
For value e, it will give you value 1. So it is e comma 1. Note it down.
Okay.
Okay. Now let us discuss your doubt. So they have given us the graph of log of x plus 3.
Mm-hmm.
Now the graph passes through 6 comma 2. Okay, p is the base. Now the graph passes through 6 comma 2. Okay, this is the point. And x intercept, do you know x intercept, that how much it is intercepting on the x axis?
Yeah.
See, here it is intercepting 2, and on the negative side, so this point will be minus 2 comma 0.
Mm-hmm.
Asymptote is that line which graph is tending but not going to touch it. Okay, so they're asking for find p.
Mm-hmm.
Okay, so if they have given us 6 comma 2, that means what? For x equal to 6, we are getting what? F of 6 to be 2, right?
Yeah.
So that means log 6 plus 3 to the base p will be 2. That means log 9 to the base p will be 2. That means what? P power 2 equals to 9, right?
Mm-hmm.
And I can see that, okay, this will be 3 then, because we know that 3 square is 9.
Yeah.
So p is 3.
Okay.
Now the graph of the f is reflected in the line y equal to x to give the graph of g. See, always remember one thing. Okay, if you can see that thing. Okay, I'm zooming out a little bit. That okay, let me show you here only. See the graph of log and exponents. They are inverse of each other. Like they are. Just a second. This is y equal to x line, right?
Yeah.
Now this was your a per x graph, right?
Mm-hmm.
This point was 1 comma 0 comma 1, and this was your exponents graph. So can you see that ln x and a per x are what? Reflection of each other in the line y equal to x.
Yeah.
This point is c 0 1 comma 0.
Mm-hmm.
So always remember that thing, that exponent and logarithm are reflection of each other in the y equal to x line. So let's say if I say log a to the base b okay, is there. Okay, it is fx, and I'm saying that I have reflected it over the y equal to x line. Okay, then I got the gx function. So what it will be? It will be b per a.
Yeah.
Note it down.
Yeah, I already know.
Okay, so here you can see that they're saying that f is reflected over the line y equal to x to give g. So g will be what? 3 raised to power, see, 3 raised to power, sorry, 3 raised to power x plus 3.
Mm-hmm.
Okay, so g of x is 3 raised to power x plus 3. Now, how to calculate y-intercept? To calculate y-intercept, we put x equal to 0.
Okay.
To calculate x-intercept, we put y equal to 0. This is the basic methodology.
Yeah.
So, for question number 1, the answer will be, if I put x equal to 0, this will become 3 power 0 plus 3. That is 3 power 3, that will be 27.
Okay.
And if you want to sketch it, so simple, like you take the mirror image in the y equal to x line. So that will be what? If I draw the y equal to x line, if you take the screenshot of it, okay, so this will become, I guess, like this. Are you able to see that how red one is the
Yeah.
reflection?
Yeah.
Okay, that will be it. And the graph is reflected on the line y equal to x. To give the graph, find g of x. So g of x was what? That was 3 per x plus 3.
Okay.
For G, it is the asymptote.
Okay.
Definitely a good question, but I hope you got it.
Yeah.
See, we cannot complete like any topic in any one class. Okay, like okay, we have done it, but definitely it depends on the practice part that how much we are comfortable with the topic. Okay,
Mm-hmm.
so I hope like okay, you wanted to discuss many topics, but okay, we
Yeah.
just focused on one topic, and that was enough for one class. I guess so. Like okay, we learned each and everything from very scratch, from very basics, right?
Mm-hmm.
So we have covered 1.5 and 1.7.
Yeah.
Now I don't think you should face any trouble, but yeah, definitely do the revision part today. Okay.
Yeah. Well.
Okay. So
Okay. So for A, I got p to the power of 5. Oh, I can't hear you.
you have to give me the value p and q. Okay. So p is what? 5, right?
Yeah.
Q is q only.
Yeah.
What will be the value p here? 15 by 2,
Yeah.
because that 15 will come outside. So this will become 15 by 2
Yeah.
log x to the base q, right?
Yeah.
Here what will become the p?
It would be 1/3.
1 over 3. Excellent. Here
10.
uh, see, if we can multiply it, right?
Mm-hmm.
So power gets added, not multiplied.
Oh, so 7.
Yes.
Okay.
Now solve G and H also then. Then we'll
For G, does it say LOQ and then Q again?
see, we have log Q 1 by x square plus log Q 1 by x cube.
Mm-hmm.
So first of all we can multiply it, right?
Yeah.
So this will become log Q, and 1 by x square into 1 by x cube will be 1 by x bar 5, right?
Mm-hmm.
So we can write it to be x bar minus 5, or
Yeah.
minus 5 log x to the base q, right? Similarly, if we go for the h part, so just a second, this will become 6 log x to the base q, right?
Mm-hmm.
And minus 4 by 2 will be 2, right?
Yeah.
So this will ultimately become 4 log x to the base q.
Okay.
The p is 4 here. So any other doubts from your side?
No.
Okay, so I think we have done a lot of question today. I
Mhm.
hope you are very much clear about this topic now,
Yeah.
and I hope you found it interesting also. Like, okay, I tried to make it more interesting that you should get all the reasons behind each and every formula.
Yeah.
Okay, okay. So see, yeah, we'll meet tomorrow and we'll do like okay, the upcoming subtopics or whatever we decide to do. Okay.
Okay.
Okay, Sana. So all the very best. Try to do as much as you can. Okay. Don't worry. Right now, like we have just started our syllabus. Okay. With time and with practice. Okay. Trust me. Like within few times only. Like okay, at least let us give few weeks. Okay, to us. Then definitely we'll do rock in maths. Okay. So don't worry about that.
Thank
Oh,
you.
okay, Sana. So see you. Take care. Bye.
Okay.